Hi class, I do have a video that has the computational formula, but I also wanted to go ahead and create a video using the same data with the definitional formula. So we are going to start with some data, making it simple for our practice. Okay, and so when we do the definitional formula for sum of squares, it simply is the sum of squared deviations. So the sum of squared deviations is the sum of squared deviations. So to do that one, we are going to need to calculate our mean, which we will get to in a minute. And we are going to have it set up in this fashion, right? So our mean is going to be the sum of x over n. And so we're going to sum up our x. If we sum this up, we get 1 plus 2 plus 3 plus 5 plus 4, which equals 15. So then our mean is going to equal 15 over 1, 2, 3, 4, 5, 5, which equals 3. We are now going to do our columns. And remember, the beauty of this is this should always sum to 0, right? So then we're going to figure that out. And that does sum to 0. So now we're going to take each of these answers and we're going to square them. Remember, a negative times a negative is a positive. And we are going to sum this up, and we have 4 plus 1 plus 0 plus 4 plus 1, and we get 10. That is our sum of squares. All right, so then normally when we calculate sum of squares, we calculate it for standard deviation and variance. And we most commonly use a sample. And minus 1, remember that equals that degrees of freedom. That's kind of the difference in the formulas. So then we have the square root of 10 over 5 minus 1 is 4, and then we calculate that. Remember that, again, as I showed in the other video, s squared is variance, and that is just going to be sum of squares over degrees of freedom, which is going to be that 10 over 4. So then I just need to take the square root for 2.5. And when I do that, go to 1.58. All right, and there you go. Hope this was